We're now going to look at a unique matrix called an identity matrix, and it looks like this. So the first row, if it's a 2 by 2 matrix in this case, will be 1, 0, and then 0, 1 in the second row. So the symbol for this matrix, we're just going to give I for identity matrix. So we're going to look at 3 problems with identity matrix. The first 2, we're going to have our normal matrix multiplied by our identity matrix. And then in this third problem, we're going to have our identity matrix first multiplied by another matrix and just see what happens. So we'll call this one matrix A multiplied by our identity matrix. So the same way as we normally would. So it would be 1 times 1 plus 2 times 0. And then we'll do that same row down the second column. So it would be 1 times 0 plus 2 times 1. And then we'll go on to our second row. So second row multiplied by the first column. And then our second row multiplied by our second column. And if we were to solve this, 1 plus 0 is 1, 0 plus 2 is 2, and 3 times 0 is 3, and 0 times 4 is 4. There's our answer for that. Let's have a look at the second example. Minus 1 times and 2, 1, 0 times another identity matrix. And we'll do the same thing. First row by the first column. And then the first row by the second column. And then the second row by the first column. And then the second row by the second column. So hopefully you are really confident with this pattern now. Let's solve it. Minus 1 plus 0. 0 plus 2. 1 plus 0. And 0 plus 0. And that's the answer to our second problem. So in our first problem, we have this this matrix A multiplied by our identity matrix, and our result is the same answer as matrix A. That's the unique thing about multiplying an identity matrix by any normal matrix. Let's have a look at this. Matrix A, we multiply it by our identity matrix, and we come up with matrix A in our answer. So that's something to remember. If you see this arrangement, anything multiplied by that, you can go straight away to the answer. Okay. Let's have a look at a similar but different example. This time we're going to put the identity matrix first. So here's I, and then we're going to multiply it by, we'll call it matrix A again, and see what actually happens. So 1 times 5 plus 0 times 3, and then we'll do the first row by the second column again. Second row by the first column. and the second row by the second column. And solve. 5 plus 0 is 5. 10 times 0 is 10. 3 and 4. So you can see that if we have our identity matrix first, multiply it by our matrix A, we still come up with our matrix A. So it doesn't matter which order the identity matrix is in, you'll still come up with the answer for our normal matrix. So that's something that would be worth remembering. So here's sort of a general rule. The matrix I for identity matrix, in the example that we've done, is a 2 by 2 identity matrix. So the rule is for any matrix A, now that's the one that you're looking at, the identity matrix times by your matrix will give your matrix. Or alternatively, you could have, like in our first two examples, your matrix times by an identity matrix will give your matrix. Identity matrices are always square. Okay, so that means they could be a 2 by 2, or they might be a 3 by 3 arrangement, and so forth. Let's have a look at what a 3 by 3 identity matrix looks like. So you need to remember that and have that on your formula sheet as well. Using your calculator, we're going to test the 3 by 3 identity matrix on just a random made up matrix. So I'm just going to make one up. I want you to use your calculator to do this. So I'm just going to make this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 by 3. And I'm going to test that this is going to result in this being the answer. Okay, that fits with our rule. Your matrix or matrix A times an identity matrix will equal matrix A. I want you to do that in the calculator to show that that is true. Does the identity work for regular matrices? Okay, you can do this by pen and paper if you wish, or you can just go straight to your calculator, which is what I would suggest. If you did it by pen and paper, remember it would be 1 by 2, 0 by 1, and then it would be 1 by 0, 0 by 3, and then this time you'd have a third column, 1 by 3, 0 by 4, but more easily, and put this in your calculator, you should end up with these numbers, and I want you to do that. Okay, we've got a 3 by 3 identity matrix here with a regular matrix. I want you to do in your calculator and see if you come up with that same answer. Okay, your turn now on page 34. Question 41, okay, is similar to the ones that we were doing in the first part of this video. And then question 42 is what would the order of the matrix actually look like? Okay, so if we have these ones as an example, these are 2 by 2, and this is 2 by 3. Okay. This one actually works because both of the column in the first one matches the rows in the second one. So you've got to make sure that you can remember that rule. This one is a 2 by 3 matrix, and this is a 3 by 3 matrix. Again, this one works because 3 columns matches 3 rows. So you need to, in those examples, work out what the order would be for your matrix when you get to question 42. Have a go.